I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Every machine around us produces heat. Car engines, aircraft turbines, even the laptop you're using right now, they all waste enormous amounts of energy as heat. In fact, over half of the world's energy is simply lost this way. But what if that wasted heat could be turned back into power? That's the promise of heat-to-power technology and thermoelectrics. Think of it like recycling energy. Thermoelectrics use a fascinating principle called the Seebeck effect. When one side of a material is hot and the other side is cool, a voltage is created. It's solid state. No moving parts, no noise, no maintenance. Just pure energy from temperature differences. And the possibilities are enormous. Data centers, for example, convert more than 98% of their electricity into low-grade heat. Right now, we spend even more electricity to cool those servers. But with thermoelectric generators, that waste heat can be converted back into power, reducing costs and carbon emissions at the same time. Cars are another big opportunity. Did you know that 2/3 of the energy from gasoline engines is lost as heat? By capturing exhaust heat with thermoelectric devices, vehicles could recharge their own batteries or power onboard systems. Prototypes have already shown fuel efficiency gains of up to 3%. And that's just the beginning. For electric vehicles, every bit of extra energy means longer range. Now, let's zoom into something more personal: the human body. At rest, your body gives off about 100 watts of heat, like a glowing light bulb. Today, researchers are developing wearable thermoelectrics that can harvest just a tiny fraction of that, a few milliwatts, enough to power a fitness tracker, a smartwatch, or a medical sensor without ever needing a charger. Imagine a future where your smartwatch never runs out of battery because it runs on you. Then there's thermophotovoltaics, or TPV, one of the most exciting frontiers. Instead of turning sunlight into electricity, TPV turns high-temperature heat into infrared lights and then into power. Think of it like a solar panel for heat. Recent experiments have achieved over 44% efficiency, with a clear path to more than 50%. That's double the efficiency of many commercial solar panels. And when combined with advanced thermal storage materials that can hold heat for hours or even days, TPV could deliver electricity on demand, even when the sun isn't shining. The potential applications go far beyond homes and cars. Consumer electronics like laptops and smartphones could soon recharge themselves by reusing the heat they already generate. In factories, thermoelectrics could harvest heat from glass furnaces and metal production, saving megawatts of power that would otherwise vanish into the air. And in space, this technology is already proven. NASA's Voyager spacecraft, launched in the 1970s, are still powered by radioisotope thermoelectric generators, silent, maintenance-free, and reliable for decades. That same concept is now being adapted for Earth-based uses. The military is also eyeing the benefits. Soldiers carry more than 10 kilograms of batteries into the field. With uniforms or gear embedded with thermoelectric fabrics, they could power radios, sensors, and GPS devices using nothing but body heat or vehicle exhaust, reducing weight and boosting mission endurance. Of course, challenges remain. Today's thermoelectric systems operate at around 5 to 15% efficiency. Materials are improving fast, though. Nanotechnology and new composites like bismuth telluride, scooterites, and graphene are pushing performance higher while lowering costs. Flexible versions are already being tested that can bend and stretch like fabric. Market analysts project that thermoelectric generators will reach a $1.4 billion market by 2030. As efficiency rises and costs fall, adoption will spread across wearables, consumer devices, homes, transport, and heavy industry. So, here's the big picture. Heat is everywhere. It's constant, it's powerful, and until now, it's been wasted. Heat-to-power technology and thermoelectrics promise a future where energy doesn't just vanish. It gets recycled back into our lives. From powering your watch with your own body heat, to fueling spacecraft across the solar system, to cutting emissions from the world's biggest industries, this is one of the most exciting steps towards true energy resilience. The future of energy isn't just electric, it's thermoelectric. And 1 degree at a time, it could transform the way we power the world.
Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.